Hi everyone, this is Navin Kumar and my team members are Rohit Vijayvargi, Srikanth Yadav and Shashidhar. We are from Computer Science Department. Our project is all about phrase-based clustering of text documents using suffix tree. We did this project under the esteemed guidance of Srimati Nadalla Sandhya Garu, Assistant Professor of Computer Science. Our project is based on clustering, which is a concept of data mining. Data mining means mining or extracting knowledge from large collection of information. And clustering is a process of organizing similar objects into groups, and therefore a cluster is a collection of similar objects. Our project is a web-based application. As you all know that the amount of information on internet is growing at an enormous rate, and finding relevant information is becoming increasingly difficult. Suppose you are searching for something on net. You will type a particular phrase relevant to your search in search engine. The moment you press enter or search button, hundreds or thousands of snippets will be displayed on your system, and the user will view a maximum of 20 to 25 snippets. It becomes cumbersome for user to view all the snippets, and also not all the snippets will contain the relevant phrase you are searching. In order to overcome this problem, we have implemented phrase-based clustering of text documents, where we cluster the documents based on phrases, where a phrase is an order sequence of words limited by a phrase boundary. Many clustering algorithms have been developed, including k-means, hierarchical agglomerative clustering, and suffix tree clustering. We use suffix tree clustering for our document clustering. It uses phrases rather than words, and that it allows clusters to overlap. Our project involves these steps: pre-processing of text documents, generation of suffixes, construction of generalized suffix tree, DFS traversal, clustering based on k-mismatch concepts. First step is pre-processing of text documents. Here we need to perform the following steps. Better I will explain these by using a notepad. Here the first step is splitting the documents contents in line wise, that is like this. And the next step is removing the unwanted characters. Unwanted characters are nothing but special symbols like double quotes, and these are the special symbols. And the next step is converting uppercase to lowercase, and that is okay. And the next step is removal of stop words. Stop words are nothing but most frequently used words like and, but, if, how, etc. Like here this is a frequently used word, so we have to remove it. And in the similar way, is a frequently used word, and am, from, and Mr. is also a stop word, and hence the first step is pre-processing of text documents. Here we need to perform the following steps. I will explain these steps using a sample text documents, and here it is. The first step is to split the document content line wise, that is like this. And the second step is removing unwanted characters. Unwanted characters are nothing but punctuation marks and special symbols like double quotes, exclamatory marks, and we should remove those. And the third step is conversion from uppercase to lowercase, and here CSC greet is in uppercase, we need to convert it into lowercase. All the letters from higher to lower. And the first step is removal of stop words. Stop words are nothing but most frequently used like but, and, if, is, that. In this document, is, this, these are frequently used words. And from and am are also frequently used words. And from these documents, this is the text which are given to Porter stemming algorithm. And at last, perform stemming. We use Porter stemming algorithm in order to accomplish this. And the next step is generation of suffixes. Let us consider the following three documents. And these are the three documents. Each document may contain one or more lines. And the next step is generating suffixes for these documents. Here are the suffixes. These are the suffixes for document D1, and these are the suffixes for document D2, and these are the suffixes for document D3. Here we can see that Rahul is the suffix which is present in both the documents, and hence it is a duplicate. It will be removed while removing the duplicates. And next step is merging those all suffixes into a single document and removing the duplicates. After generating unique suffixes, we move on to build generalized suffix tree. Generalized suffix tree construction needs to follow these 4 steps, and here is the generalized suffix tree for our sample 3 documents as we shown earlier. After generating suffixes, we perform DFS traversal to find word sequences which will be further used in clustering, and this is the result we obtained after performing DFS traversal on suffix tree for the 3 sample documents which we have discussed earlier. Here each row is called cluster candidate, and this cluster candidate consists of word sequence and the document IDs to which that particular phrase belongs. After clustering, we will get 3 cluster candidates. Those are CC1, CC2, CC3. CC1 consisting word sequence as Rahul and document IDs as d1.txt, d2.txt and d3.txt, which means Rahul is the frequency. After performing the DFS traversal, the next step is clustering of text documents. Each word sequence with document IDs obtained from DFS traversal is treated as a cluster candidate. A cluster candidate is a set of text documents. A cluster candidate I is represented by CCI of WSI and IDSI, in which WSI is the word sequence supported by this cluster candidate and IDSI is the set of document IDs, which means Rahul is the word sequence containing in these document IDs, that is D1, D2 and D3, and principal sir is the word sequence containing in d3.txt and d2.txt, and here it is the note. Here the support count is taken as 2, which means that a particular word sequence WS must occur in at least 2 documents so that it is considered as a cluster. After getting these cluster candidates, we merge these cluster candidates based on the k-mismatch concept. In k-mismatch concept, we have 3 types of mismatches, namely insertion, deletion and substitution. After getting these cluster candidates, we merge these cluster candidates based on the k-mismatch concept. In k-mismatch concept, we have 3 types of mismatches, namely insertion, deletion and substitution. Let me explain with the following example. In case of insertion here, word sequence I equal to principal sir and word sequence j equal to sir. By inserting the word principal in WSJ, word sequence j, then it will be equal to word sequence I. In case of deletion, the word sequence ith word sequence is principal sir and the jth word sequence is sir. By deleting principal from the WSI, it is equal to WSJ. In this way, we have to merge all the cluster candidates. After merging the cluster candidates, we will get the clusters. Then we have to combine these clusters by using the following measure. Here C of I is the number of document IDs in ith cluster, and C of j is the number of document IDs in jth cluster. If the value of O of Ci, Cj is larger than the specified overlap threshold value d, these two clusters in this measure, C of I is the document IDs in ith cluster and C of j is the document IDs in jth cluster. If the value of this is larger than the specified overlap threshold value d, these two clusters are combined into one cluster. In the end, we collect these documents that are not in any cluster because they do not contain a frequent word sequence. These documents form a cluster of themselves, and these are the references. Thank you.